The main topic in this next video will be debugging, but before we get there, I want to just wrap up a couple of things in functions. So I do want to emphasize, and you probably noticed, that when you call a function from within some other function, for example, from main, let's say you call the function square, you don't need anything like a class name or an object name or any of that. That's because the structure of C is pretty flat. That is, functions are all sort of at one level. Even if they're outside your source code, they're still at sort of this one flat level. And so there's no hierarchy. You don't need a class name or anything like that. Okay, so that is important when you consider input and output. I/O is done with just function calls, and there's no class name, none of that. You don't need to import anything. You don't need to import classes, but you do need to include stdio.h. .h. If you do, once you do that, then you can use things like printf, and there's other I/O functions as well. The most simple one is printf. So what printf does is print to the standard out, which is the terminal. Okay, and you've probably run this program. You've seen how this behaves. You just get this thing printed. You get a new line with \n. Okay, so on to the main topic, that is debugging. There's a number of debuggers that we can use in Unix, but the standard one is the new debugger, or the new debugger GDB, which can be used to debug programs written in C, C++, or assembly code, or actually a number of other languages. But these are the ones that we'll be interested in: C, C++, maybe assembly code. Running a program within GDB allows you to check values of variables, check and make sure that it's going to the right places when you have control flow, things like that. So let's see how we can do this. So we'll take our sample program. That is first. We compiled it, we ran it, and it turns out you have to recompile it to use the debugger. But let's just pretend that we didn't know that. And let's just try to run this executable using GDB. So what do? Do you say GDB first.c? No, you say GDB first. That is the executable. So you say GDB and, GDB first. Okay. So this will give us some messages. The first thing you want to do is list. And then you get this message saying no symbol table is loaded. If you ever see this, then you know for sure that you have to recompile your source code with debugging enabled. So you can actually run this program, but you cannot really do everything that you need to do when you debug. So you can actually run this, and it'll do the right thing. That is, it'll print out what it's supposed to print out, which is hello world, and it'll say program exited normally, but you cannot really debug it. So let's quit out of here, and let's see what needs to be done. So before you can actually debug a C program, what you need to do is compile that program with the -G flag for debug, and then you say -O first, and we'll do this all in one step. We won't create the object code. So you can do this: GCC -G for debug mode, -O, that's the output, should be called first, and you're going to compile first.c. Okay. And this time around, you can see that the first.c is still there. First is a new one. You can check the date and stuff like that. And you won't see this on Linux systems, but on the Mac OS X, you actually get a file that contains part of the symbol table, and all of that is sort of handled differently in Linux. So you won't see this file in Linux, but you do see it on Mac OS X. Okay, so disregard that. Then you say GDB first. And now what you want to say is list. And then what that does, if everything works, it will list your program. And if at this point, that is, if you're running GDB and you say list and you see, I think by default you get 10 lines. This program is actually shorter than 10 lines, so you only get 5. If you say list and you see your program, then you're in good shape. Okay, so that means everything is all ready, and you can say things like break at 3. Oops. Let's see. Maybe it's break 3. Okay. So break puts a breakpoint at line 3. If you list it and you say list 1, it's not obvious that it's there. And so now what I want to do is what I've done is set a breakpoint at line 3, and then I'll say run. And sure enough, it worked. It started the program, and then it said there's a breakpoint, so it's just about to execute this line, but it hasn't yet. And so what I can say is I can say next, and what that does is executes just the next line of code, which is the printf, which prints out hello world, and then it's stopped at the return 0. I can say next again, and it's basically done. So at this point you can rerun it if you want to, and it'll ask you, do you want to start from the beginning? You say yes, and it'll go back to the breakpoint, and then you can say continue, and it can keep going. And in this case it just exits normally. Okay, so that's a quick introduction to GDB. We'll be talking about all of this stuff in more detail next. Okay, so as it says in the notes, you have to say gcc, and to fully use the debugger you have to use the -g. If you say -o first.c, you won't create all the debug information that it needs, that GDB needs to effectively debug it. So you can say cc -o without the -g flag, and then you can run it. You can say GDB first and run it. It'll execute, and then you can quit. That's fine. Okay, but to really be able to use GDB, you have to have that -g flag. So you have to compile in debug mode to be able to use most of the features of GDB. Once you do that, then you can say GDB first, and you can list it, and you will see all the lines of the code. You can set breakpoints, break at whatever line. You'll see the line numbers when you're in GDB, and pick a line number. And you have to choose a line number where you have an executable statement. So when you say break, that number should be some line number that corresponds to an executable statement. So then once you do that and you run, it'll stop at the breakpoint, and then you can do next or continue or whatever. So try that out before you go ahead. Pause this video. Make sure that you can actually step through a simple C program. Okay, so some common GDB commands that you would probably need to pretty much memorize. It's not that hard. Help is a good one. Next, to step over a single statement. If you are calling a function and you want to step into that function, you say step rather than next. So if it's just a statement like a is equal to b plus c, then next and step will have the same effect. But if you're saying a is equal to square root of b, then step will step into the square root function, whereas next will just sort of skip over square root and just go to the next statement. As we saw, break sets a breakpoint, run starts program execution from the very beginning, continue is usually done after you hit a breakpoint, and then you can continue till the next breakpoint or till the program finishes execution. You can also print values if you have variables. You can print the value of a variable or an expression. So you can say 3 times x or something like that, or x plus 5. So there are some more useful GDB commands. Kill will stop a running program. If it's running in the background, you can use kill. You can delete breakpoints by saying delete and then the breakpoint number. You can use info to get current status of the stack, breakpoints, functions, variables, memory, registers, scope, frame, whole bunch of things. If you say display x, for example, where x is an actual variable in your program, what that will do is every time you do a next or a step or whatever, continue, it will show the value of that variable at every point. Every time it takes sort of a break, when you get the prompt, every time you get a prompt, you will get the values of those variables displayed. So display is different from print in that if you're, let's say, in a loop and you want to have the value of some variable refreshed every time you step, you can use display. Whereas print just prints it that one time. And so what you want to do is now go through a bunch of these files, bunch of these programs, and try to figure out what is wrong with some of these programs. So I'm going to stop this video, and then you want to take a look at these programs that's in the notes and try to figure out what might possibly be wrong. And so main things, you want to get familiar with the debugger.